Okay, this video is about how to get your Rix Expert's AA02 working. I got mine working, almost gave up on it, but I didn't. So there was 5 problems that I found, and it comes down to errors and omissions. Either their website is wrong in some things, such as code and documentation, or they just don't even mention some of the things you need to know. But I put together a link so that you can get all this stuff in one place and get this working as easy as possible. All right, so first of all, the board is shipped with the wrong firmware. All right, they're shipping it with 115K baud UART software. And they tell you right on their website that it will not work on the Arduino, that you need to reflash it with the 38.4. Okay, so if you click on that link is broken. So the first problem is they ship it with the wrong stuff. They make your life a little difficult. And then second of all, they give you a teaser hint that you need to reflash it, but the link is broken. And third of all, most people did not know that this orangey tape is actually covering a slide switch that provides power for either from the USB source or from an external source. So I want to show you what the tape looks like. So that's the little piece of orangey yellow tape that you need to remove from the slide switch. Okay, and then that'll give you a slide switch that looks like this. Now these are the this is the edge connector that you have to solder the pins in. You can tell by the silk screening where this is located at. I got the switch in 2 different positions, but it's actually hard to tell with the microscope view. So you need to slide this up towards USB when you reflash it. When you're powering it by your I/O pins, you need to slide it down for external power. Slide switch, but that is a slide switch. Some people thought it was a transformer, some people thought it was a voltage regulator. Then the website says you can provide external power from 3 to 48 volts. Well, that's wrong. I don't know what the minimum voltage is, but I know 3.3 does not work and 5 does. So I think this is a typo. I think that should be 5 volts to 48 volts. And then once you reflash it and move the slide switch in the right position, you can download their code and get it working on an Arduino. But unfortunately not on an ESP32 or anything else, because they transfer IEEE 754 floating point values in binary. I've never seen anyone transfer data in binary format for floating point numbers. Most people use ASCII strings and they convert back and forth, and yes, it's a little bit slower, but it seems like it's a little bit safer. So, do they use the word float? No, they use the word double. So the code is wrong right off the bat, but there's a saving grace here. The Arduino floats and doubles are the same size. They're both 4 bytes. So if you do a size of float in C and a size of double in C, you'll get 4 for each of those. But in my case, I was using an ESP32 and it did not work. So I had to change that value from a double to a float. So that's just bad documentation. But they make great hardware. They got bad documentation. They got bad portable code. The code works on Arduino, doesn't work on anything else. Their code was put into the public domain. I took the code, I modified it, I got it working for an ESP32 and for an Arduino, and I put it back into the public domain. All right. So it's not under an MIT or a GNU license. There's no licensing mention at all. I didn't add any licensing mention. I just left it back into the public domain. They finally responded to my email from May 2nd in mid-June. So that's pretty slow. And that was only one of 3 emails that they responded to. I got a feeling that they probably seen this video and says, oh, I don't think we want to talk to this guy. I'm probably on their bad side, even though I'm helping you get this working and kind of knocking all the bad things they did. But I think they should learn from this and clean it up. So I cleaned up the code. You can see I added an error counter. I tweaked it. I optimized it for speed using a logic analyzer. They were polling the status all the time, and I'm thinking, you're hitting that 8-bit micro so often that it's really not necessary to do that. And you're just slowing it down. So I kind of waited, and I knew it wasn't going to reply until about 65 milliseconds. So I figured I can sleep until then and then do some statuses and get it. Then I would actually get them faster, get the answer faster by not, taxing the STM32 microprocessor. So they're using an STM32F on their board, and that's using the IEEE 754 floating point format, and they're transferring those 4 bytes in binary. Okay, so take the tape off your slide switch and move your slide switch around, and make sure that that you have external power of at least 5 volts. And this is a little video of a board that I've been working on. This is an STM32. I got rect and text, as they say. So between rectangles and text, I got a better display than they do on their Rix Expert products. So this is 420 pixels across and 320 pixels down, 16-bit color. And here's an SWR plot of a Comet 2-meter antenna. You can see the SWR is low on this white line, and it's a 440 antenna, and it starts dropping down here. And you got your cyan colored line for your X, which gives you L when it's positive, and minus for C. I also have a frequency mode. You can tweak the SWR here. Sorry for the shaky camera. But yeah, I plan to make circuit boards. If you're interested in building this, I don't know if I'm going to release the source code just yet, but I will be doing, this will be ESP32 based. That's up there. It has a laser infrared measurement, so you can build antennas and tune them up to 4 meters long, so you can measure to a 1/16 of an inch easily how long your antenna is. So it'll give you length and like one of the things you could see here. At 100 megahertz, a quarter wave is 2 feet, 0.34, or 2 feet, 4 and 1/16. At a half wave, 3/4 wave, and at a full wave, you've got a bug in there. Yeah, so this is still code in progress, work in progress here. But, we're going to give you everything that they give you out of the AA030, which basically they give you R, X, and everything else is calculated. You give it Z0 of 50 ohms. This software will let you input any value from 25 to 600. So if you want to enter 52.7, you're free to do that, whereas the Rix Experts just give you fixed menu items. So this has been a challenging little project. It's been fun. It's, I think, better than theirs, and it probably cost under $200, and it covers 100 kilohertz to 1 gigahertz. It does not have the coax time domain, reflection, because that's not part of the AA030. But I'll give you a link of wb9raa.com/AA02, and I'll post that on the video here, on where to get the files, how to flash them, how to get it working in TTL RS-232 at only 38.4 baud, 38,400 baud, because that's all they support, and also how to get it working on the I2C. Now the I2C is faster than the I2C is faster than the UART because you got 38,000 kilohertz or 38,000 baud versus 100K baud, and the UART has a CRC table, so every byte they send has a complement, as a CRC and a CRC complement, so every byte has an extra 2 bytes that tag along, whereas the I2C just has 1 byte. There is no CRC table, so it's less code. You don't have 256 bytes wasted on a CRC table, and not really wasted, but you don't have it taken. And then you don't have, you know, to transmit those extra bytes, and that's why it's a little bit faster. But anyway, hope this all helps you, and get you working with all this stuff. It's a shame they did what they did, but that's my story. Okay, give me a like and a subscribe if this is helpful to you, and keep the conversation going. Let me know if you're interested in circuit boards. I will be making circuit boards in the next week or so, and still finishing up a lot of the different menus and code items. One of the things I can do, I can scan 100 kilohertz to 999.99 megahertz and give you a list of frequencies where all the SWR is under 2 or under 1.5 or under 1.75 or whatever value you want to pick from a menu. We got a quad screen display that'll show 4 little graphs, but yeah, I'm doing 108 points. You could run at high resolution, 108 points, or 54 or 36, depending on how long you want to wait. This is about 20 seconds, and then of course this is half, so this is about 10, and this is about a 5-second scan, which is a little rougher. You can just kind of see that the points, this is very smooth. All right, thanks for watching. See you guys later.